Hello, this is John from caveofprogramming.com. In this tutorial, we're just going to write a little stub for our fractal class. So we're going to implement the mandelbrot fractal here. It's a good idea to Google that if you don't know it. You'll see how it's spelt in just a minute. We could go on to improve this program and create like a hierarchy of different fractal classes or something, or at least have a base class and multiple different fractals, but we're just going to create one here in this tutorial, and it's going to be the mandelbrot fractal. So let's right click the project here and go to new class, and I'll call this mandelbrot, which is spelled like mandelbrot. Some people say mandelbrot, but I think his name is more like mandelbrot, the guy who came up with this algorithm, that is. So we're going to just click finish here. I'm not going to use the constructor and destructor, but we'll leave it there. It might be handy to have, possibly if you improve this project somehow. Now, the way this algorithm works is you pass to it some coordinates, which, as we've seen, have to range from, if you want to see the whole thing, it's something like -1 to +1 for x and y. So we pass it 2 coordinates, or at least that should at least enable us to see something on the screen. So we pass it those coordinates, and it's going to go through a bunch of iterations. It's going to do a loop, and that loop is going to finish for some coordinates, and for others it's not, and we're just going to have to finish it so it doesn't go on forever. So I won't get too deeply into the intricacies of the mandelbrot fractal, but I just wanted to explain that we're going to be getting a number of iterations of a loop basically, and we're going to use that to figure out what color to actually plot for a particular pixel. So here we need a method, something like int, let's call it get iterations, and we're going to pass to it $x and $y. And I'm going to make this, let's make this static, because we're not actually going to need any instance variables here. It's just going to be a really simple static method. So I'm going to copy that and go to mandelbrot.cpp, and we'll paste that in, and we need this qualifier, this prefix here, to say it's part of the class. We don't need this static, we can't have it here, so we'll get rid of it. That's just got to be in the header, and we'll paste that on there, and for the moment we'll just return 0 so that we can get this to compile. One other little thing I'm going to add in this tutorial is we'll create another public section up here. We could use the same section, but I'm going to split these up because I just want to have a constant here. So I'll make it separate from all this stuff, just visually. Let's make this static const int max underscore iterations, putting it in uppercase because it's a constant, and I'll set that equal to, let's try 1,000 initially. And the way this algorithm works is that the more iterations you do, or you are willing to do for each pixel, then the better quality you get for the image basically. But you have to kind of trade that off, because obviously the more iterations there are, it's going to take more time, and this is already going to be pretty lengthy, this calculation. So we'll try 1,000 to start with. I'll leave it there for this tutorial. If you want a bit of a challenge here, you could try it. Well, let's just compile it first, make sure it actually compiles, and it doesn't, so I did something stupidly wrong. I've still got the semicolon on there, and it should be a bracket. Let's just put that in, check that this compiles. So if you want a bit, I've still got a problem here. Let's just take a look. I didn't even put in the closing bracket. Well, more haste and less speed. I hope that works. There we go. Let's check this. Yeah. Okay, so if you want a bit of a challenge, what you could do is look up the mandelbrot algorithm and try to implement it here. See how far you get with that. If you can devise some really simple scheme that maps the number this returns in main.cpp, because we're going to use it right here in this nested loop in main.cpp as we go over all the pixels, and then you have to map that to a valid color. Just through a simple multiplication would do the trick actually. So you could have a go at that if you want. Just it's a good thing to look it up and see how far you get. But if you don't know anything about it, does use complex numbers, and you can do this without complex numbers. But this algorithm comes out of a background of complex numbers, and it's more elegant if you write it using complex numbers. And there is a complex number class built into C++, which we're going to see. So you could have a go at that with or without complex numbers. But otherwise, stay tuned, and in the next tutorial, we'll actually implement that algorithm. So until next time, happy coding.